So today I'm going to talk about the ANSYS Air offerings and how those can be used for gas turbines. So let me provide a little bit of background of our innovation strategy and focus. And the similar strategy and focus is used for our solution offerings for gas turbines. And these are the five major pillars behind that strategy. On the far left, you're looking at the continued focus on core physics, numerical methods, state-of-the-art models, and continuous enhancements on those multi-scale multi-physics models. High-performance computing continues to be our focus, and especially now there is a significant focus on GPUs, especially leveraging GPUs natively for CFD calculations for gas turbines. And we are also looking at uh, some of the even future technologies for computations such as quantum computing and how those can be leveraged for simulations. Artificial intelligence and machine learning, which is going to be the focus of today's presentation, is also one of the major pillars which can be really leveraged to reduce the cycle time substantially using things such as solver accelerations or the intelligent way to do the solver settings and create reduced order models or use of generative AI technology, which I'm going to talk about today. We are also continue to focus on the cloud platform and the user experience. We want to ensure that the technology, the solvers we have, the methods we have, not only can be used locally on edge effectively, but also can be used equally effectively, equally easily on the cloud. And a lot of technologies such as model-based systems engineering, digital twins, simulation process and data management, machine engineering, which become part of our intelligent engineering pillar. So, these are the five important pillars of our overall strategy and focus, which we also use for our gas turbine strategy. And today, I'm going to focus on AI ML. And our AI offering through Ansys AI includes three major parts, as I listed here. Answer GPT is basically a natural language assistant for documentation and training. You can think of that as a very simple, natural user interface for getting answers to your daily usage of our products. So it's much more interactive. You can uh, interactively ask questions and keep on building on uh, your questions in context of a specific problem you're dealing uh, in your uh, uh, day-to-day design um, simulation practice. Let me go to the far left, ANSYS AI Plus, which represents the AI add-ons to our ANSYS products across our portfolio. And there are several AI add-ons to all these ANSYS simulation products, and I'm going to cover a couple of them, which really enhances the simulations and also, again, targeted towards really accelerating the the solution time and eventually plug that into the accelerating the design cycle time. And the major focus of today's presentation is going to be Ansys Sim AI, which is basically a machine learning platform for simulation across all physics. It's extremely fast and reliable to carry out physics predictions, which uh, which are derived from the training data sets, which can be which can be already existing or can be generated to create these AI models. And once these AI models are ready, these are extremely fast to carry out the predictions. And hence, this offering really helps to significantly several orders of magnitude increase in the targeted areas of the overall product cycle. So uh, let me talk a little bit about the SIM AI and how it works. So as I mentioned, it starts with using your past data or existing data. You can upload that data to this platform, machine learning platform, which is used to train an AI model. And once that AI model is ready, it can then start predicting the provided new designs in matter of seconds. And uh, because of this significant speed of prediction, this offering really helps, as I mentioned, to accelerate the targeted areas of the product development. Now, the Ansys Sim AI is our cloud-based AI platform. You can train this AI without having to parameterize your geometry, and that's a significant differentiator. You can predict the performance across the design changes, even when the geometry structure is inconsistent, and you can leverage previously generated simulation results, either from the ANSYS solvers or your in-house solvers or third-party solvers, all that existing previously generated simulation data can be used to train the model. And most important is the SimAI, ANSYS SimAI is physics neutral. It can really work for any physics, such as fluids, structures, electromagnetics, optics. It can work for any different applications, industry segments, such as aerospace and defense, automotive, semiconductors, and so on. Um, and works, as I mentioned earlier, for any 3D simulation data, whether generated through the ANSYS solvers or your in-house solvers or third-party solvers. So here on the chart, I'm highlighting a typical workflow for the ANSYS SimAI. Uh, it involves typical three steps, and the first two steps are the most important ones, where you're starting with a prepare phase where you're you are using existing data or newly generated data, and in some cases even the test data uh, for training purposes. Um, and that data uh, needs to be converted into a certain format, such as a VTP formats. And that format then can be used for training an AI model. Um, so that's the prepare phase. And then is the explore phase where you can have the catalogs of the trained AI models, which can be used for prediction in matter of seconds. So the prepare phase is typically executed by the simulation experts, but once the AI model is ready, um, that AI model can be used by variety of personalities within the organization, whether they're bid managers or it can be used from design teams or stylists or or simulation expert themselves in many cases. Um, and an optional phase here, or optional step here is the validation. Though the recommended is basically validating selected best designs with the full fidelity simulation, and that is again carried out by the simulation experts. So you prepare the data, which in most cases requires using an existing data, but in some cases you might want to even generate some new data and converting that data into a format uh, which SimAI can accept, and we provide the base to do that, the process to do that, and then that data is used to train the AI model, which, when it's ready, uh, can do prediction very quickly, very easily. Now, the other way to look at this, and especially in different organizations, so in your typical organization, the typical workflow will look like this: uploading your data, which typically takes about a minute per gigabyte, and that's typically done by simulation analysts, and then you can use that data to train your AI models. And then, as mentioned in the previous chart, you can have different catalogs of the AI models for the aero analysis, mechanical analysis, electromagnetics, and so on. And once those AI models are ready, and typical time for the AI models can be few hours, uh, uh, can be up to about 2 days. But once the AI model is ready, you're basically looking at doing the predictions with those AI model in matter of seconds. And the AI predictions can be done by a variety of personas, anywhere from designers to systems engineers to architects to obviously the simulation analysts. Uh, the Answers AI offerings, and it's specifically SimAI, is really can be used for different physics. It can be used for fluids or CFD predictions. It can be used for structures, mechanical analysis, electronics or electromagnetic analysis, optics analysis, and so on. So with that background and information, let me uh, show the demonstration of SimAI. And here you're looking at how, first, how the SimAI can be used for fast prediction. And it's basically you're logging into this platform, our AI platform, and you're using the trained AI models for predictions, and you're using your geometry, which is typically the triangular representation of surfaces like STL file, and you're using that to run the prediction on a given AI model. And as I said earlier, that happens in a matter of seconds. You get a confidence score, um, which represents uh, how well you can trust these results from the AI. And then you can also post-process the results directly in SimAI. And here you can see on this bracket, you're looking at different results. The the second part here is about building the AI model itself, where, as I said, first is a preparation phase where you're creating a project name and then uploading the simulation data, just like uploading any files. here, basically, drag and drop operation is used to upload different simulation data onto this AI platform. And then you configure the model, select the variables of interest. Here, you might have many in your results file, but you can just select the the variables really for the interest of building the AI model. And then you can also specify the bounding box. Here in this particular case, we are specifying some height limits, specify how long you're willing to wait, um, and then start the training. And you wait until the AI model is ready to use. And as we said earlier, that can take a few hours up to 2 days uh, based on how much of a training data you really have. Um, but once you build that AI model is ready, uh, the predictions from that AI models really happen in a matter of seconds, as we saw in the first video, first part of the video. Now here is some guidance for the suitable SimAI evaluation. Uh, First of all physics are supported, fluids, structures, electromagnetics, electronics, optics, and so on. Typically 30 to 100 simulations for a use case. It requires surface and optionally volume data. Uh, Also, the training data sets must be uploaded to the cloud. That's where our platform is. It's cloud-based AI platform. Data can be converted to the SIMA format such as VTP or VTU, and we can help in that regard with the scripts and our overall Pythonic framework. Uh, Also, the formulas available to compute the global coefficient from the surface fills. We fully support the steady data. The transient data is also supported. Obviously, there are some constraints on how the transient data can be used. It can be a little bit tricky for some cases, but we support the steady uh, and transient data with some conditions. So with that, let me cover a few gas turbine jet engines related examples. This is a jet engine bracket generative design. Um, so one can think this as a generative AI for the jet engine applications. And the challenge we are trying to address here is coming up with a new jet engine bracket design as quickly as possible to meet specific requirements and constraints. And also, in those cases, it's important to make use of the existing designs because there can be several designs over the years, and the knowledge from those previous projects, how it can be leveraged, can also be an important aspect of the generative design. So with Ansys SimAI, the solution we provide here, we use up to 250 training samples with different and topologically diverse bracket designs to really build the global AI model. Um, and based on the knowledge from the previous projects and simulation, OptiSlang can predict the new shape, uh, while SimAI really uh, builds that AI model which predicts the physical behavior in just a few seconds. So the SimAI together with OptiSlang to um, generate the shape acts as generative AI. Um, Now, the AI model can be extended and retrained with the new designs at any time. So this is not just a static AI model. It can stay dynamic, as you keep on providing more and more training data, it can keep on learning. And that's really a key advantage of the same AI, that it's not like once you build an AI model, it's no more learning. That AI model can keep on learning based on the new training data sets. Um, and it really benefits is zero scraps. All the designs you have from the past can be used, all the knowledge can be used, even some of the failures, there's a knowledge behind those failed data, which can be leveraged in the AI model. And you can really reduce or the workflow by up to 90%. You can go directly from CAD to physics, and then you can use 100% of your team, let AI guide uh, the expertise of your team along with the knowledge from all the past and newly generated data. And here you're actually looking at some of the comparison from the SimAI predictions compared to the predictions from the Discovery Solver. The next example, this is a turbo machinery example of a centrifugal pump, and especially the use of SimAI for the design exploration. And uh, the key here is to really provide a faster optimization, much more economical approach to investigate many, many different design scenarios. So in this particular case, we use about 100 CFD simulation results to create the AI model of a centrifugal pump with different topology changes, including you can see the variation in number of blades. Um, And then once the AI model is trained using that about 100 simulation results, uh, you can see the AI predictions match really well with uh, the flagship solver data, in this case with Fluent. And the advantage you can see, clear advantage with SimAI, you get results in matter of seconds as against to an hour, more than an hour uh, with the detailed 3D CFD calculations. Um, and that really helps to reduce the design cycle time, especially you are looking to explore a wider design space and you want to really optimize your machinery. Um, there can be a significant cycle time linked with that, and that cycle time can be substantially reduced using the same AI. So now we will move on to the multi-physics. So of these first couple of examples we looked were the individual physics, fluids, structures. Now we'll look at a gas turbine specific case, which includes the structures as well as fluids physics. Um, and here again, the use of SimAI for the airfoil design and optimization. And here we are basically started looking at a gas turbine compressor. This is a first stage compressor blade. It's a transonic flow around that blade. And we had a lot of CFD and structures, static structural as well as modal analysis data. So we use those results, roughly 100, 150 simulation results on the CFD and the mechanical side to build the AI model for this gas turbine first stage compressor blade. And once that AI model was ready, we were able to predict the the new designs, which lied outside any of the training data, direct training data. We're able to predict the performance on that in matter of seconds. So here you can see the similar predictions of the flow field. And in this case, we are showing the static pressure matches very well with the validated performance from the flagship our flagship CFD solver. And here we use CFX for the validation, and you can see the flow field between SimAI and and CFX is very similar. And we did similar validations for uh, between SimAI and our mechanical solver as well. And again, the advantage here is we are going from a stage where you're looking at hours of simulation data to the seconds. And that really allows to look at much broader design space, and it also allows to optimize design much more faster. So SimAI, in combination with the data generation engine like OptiSlang, can act as a generative AI for the blade design in this case. And we just took this as one of the representative case. It can be used for any component. It can be used for any secondary flow path components or auxiliary components. But definitely the bladed components become quite attractive for the gas turbine applications because there's a lot of time spent in the design and optimization of those components. Now, I would like to move a little bit away from SimAI and talk about our AI Plus offering. And I'll cover two examples, one on the fluid side, one on the structure side. And AI Plus, as I mentioned in the beginning, these are the AI ML technologies embedded in our flagship solver. So, for example, now ANSYS Fluent has the turbulence model optimizer, which now supports the turbulence source coefficients as design variables. So adjoint plus AIML basically can be used to calibrate this Gecko model coefficients, Gecko turbulence model coefficients where you are using a high fidelity LES or hybrid RANS LES data to train uh, this AIML, making the two equation turbulence model applicable to a similar class of problems and flow scenarios. So now this turbulence model tuning with AIML is part of the ANSYS Fluids AI Plus offering. So, I mean, in a nutshell, this what really is allows you this specific capability, the turbulence model optimizer, is it allows you to have similar level of accuracy as these high fidelity calculations, like LES or hybrid RANS LES, but get that at a much lower cost with the Gecko RANS turbulence model with the upfront training using AIML and their joint technology in ANSYS Fluent. The last example I'm going to cover is on the structure side, where we can use the data to train the AI technologies embedded into our solver for resource predictions. So here you're looking at the raw anonymous solver statistics data, which can be used for the resource prediction in ANSYS Mechanical. So for uh, given class of problems, we can collect or use the collected statistics, solve the statistics to give you a guidance in terms of the computational resources for a given problem, and that uh, that is one of the most requested um, capability asked by our our users, especially from the gas turbine OEMs, and now this is part of our AI Plus offerings, uh, where it exists now in Ansys Mechanical. Uh, we provide you this ability to use this anonymous data to give you upfront, the beginning of your calculations, the resource requirements. So uh, again, I would like to uh, come back to this slide for summarizing the value of ANSYS AI, especially in context of gas turbines, which is really targeted toward shortening the gas turbine cycle time. And that is with the the power of AI. Um, the Answers AI has three different offerings. Answer GPT, which is the natural language assistant for documentation and training. AI Plus, which are the AI add-ons in several Answers products across our portfolio, which, as shown in a couple of examples today, really offer value in terms of either enhancing the user experience or or uh, and really to also accelerate the overall solution time. And finally, the SimAI, which was the major focus of today's presentation, is a machine learning platform for simulation across the physics. Uh, you can use your existing or newly generated simulation data from either ANSYS solvers or your in-house solvers or third-party solvers to train an AI model which can start predicting the new designs in matter of seconds. And again, as I mentioned several times, that really helps to accelerate the targeted portions of your product life cycle, which really helps, as I mentioned, to shorten the gas turbine cycle time substantially at the speed of AI. So with that, I'll wrap up, and please let us know if you have any questions in this regard. Thank you.